Okay, everyone had a great week this week so far. Troopers has just blown me away. The IPv6 summit and now the last 2 days of the conference has just been awesome for me. I really appreciate the ERNW team inviting me to be here and participate. It's been a goal for many, many years to come to Germany and attend Troopers. So my name is Paul Coggin. I'm from Huntsville, Alabama, born and raised in the southeast part of the U.S. A little bit about my background. I've got degrees in math, computer information systems, security, working on a third degree in systems management, systems engineering. A lot of the standard certifications everyone has. I'm a Cisco instructor. My technical background is networking primarily. I started out in systems administration, Windows, Unix, VMS, like many of you. And then but for the majority of the 20 years I've been in IT has been focused on routing and switching. Started out in enterprise, still spent a great deal of my time in enterprise networks, but also spent a great deal of time in telco service providers and critical infrastructure, utilities, SCADA, things like that. I work for Dynetics. We're a 40-year-old aerospace company. And if you have any questions afterwards you want to contact me, there's my contact info. So I'll tell you now, I got the slides I have are very detailed. I have a lot of information on them. Don't try to read all the details of the slides. I'll provide you the slides. I'll provide a lot of detail in the slides so you can look at them after the conference and study them if there's information that's interesting to you. And also provide a great deal of references for where I learned what I'm presenting today. So in networking, both offense and defense, because I do offense, ethical penetration testing, where I get hired to go in and test the security of networks and implementing security. I find that there's a big void of understanding about how the threat looks at the network. And so I'm going to focus on how the threat looks at the network infrastructure. There's a lot of conversation on the endpoints. The talk we're going to have today is about the network core infrastructure. What if the bad guys get into the routers and switches? What can they do? What can they do if they get into your enterprise routers or switches? What can they do if they get into the telecommunications company routing and switching, service providers, the cloud, as everybody calls it? I live and work in the original cloud. Remember that WAN cloud on all of our Visio drawings? So we're going to spend a great deal of time on that. So when I'm out testing these networks, doing offense or defense, when I'm looking at how to secure it, what I go and dig into is the trust relationships. There was a good presentation yesterday about trust relationships. We want to understand those vendors. What kind of remote vendor access is into the networks? Do you have vendors like was mentioned yesterday with Target? Is there a vendor, reseller, supplier that has remote access into that network? Are they using two-factor authentication, one-time passwords? If they're the service provider, who's the billing system vendor? What kind of online bill paying system do they have, and what are those trust relationships that work their way from the internet presence back into the core infrastructure, the more sensitive heart of the network? What kind of remote access does the tech staff have? Are they running a Juniper, Cisco, Huawei, Brocade? What type of network infrastructure do they have? Protocols? Very, very interested in the protocols so that we can reverse engineer the network and understand the mindset and the maturity of the technical staff that built that network. Because if you can get into the head of the network guy who built that network and understand the technology they implemented, say they're using DWDM where they're virtualizing the optical wire and splitting up lambdas. Do they understand advanced technologies like that? And most specifically, then there in the bottom, I want to call you out to where we really spend our time, both offense and defense. Is there a maturity of thinking, understanding around the control plane, the management plane, and the data plane, is separating out those three services? The control plane being how the protocols that the devices use to communicate to each other, and then the management plane, how those devices are managed. And then, of course, the data traffic, which is just the user traffic that is using that network infrastructure. But I specifically go after the control plane and management plane. And if I do a good job, if I do my homework, we're most of the time, we're very successful in getting into the networks by way of the management plane and the control plane, trust relationships. And what we do is we take all the information that we gather, the understanding that we have, and we'll develop an attack tree. If you're not familiar with attack trees, Dr. Bruce Snyder has a paper on attack trees. It's a very old paper. I suggest you go read it and look at that. And a good tool for drawing out attack trees, if you want to go back and do this in your professional practice, is look at a tool called XMind. It's free for doing mind mapping, so that you can go and draw out attack trees and draw out a strategy of how you believe the threat or adversary may be coming at your network. And I know there's a diverse group here today. If you're doing pen testing, look at how you might want to go after the network that you're under legal contract to pursue, and use that XMind tool to draw out the attack tree. What you want to do, and what we found with doing these attack trees, if we do a good job doing the intel and building a strategy, we practically have hacked the network before we ever open a laptop up, and we really ought to just go and start putting our efforts into defending and mitigation, because these attack trees are usually pretty good based on the intelligence that we gather in the OSINT. Now, I mentioned we're going to talk about what can the bad guys do to the routers and switches in your enterprise and your service provider. Well, to get things kicked off, we got to get into the router somehow. One way that we might get into the router is there's a tool that you can download, a script called SNMP Blow. It may be you need to modify the SNMP MIBs to update them for the equipment that you have today for what's in the script. But what happens with SNMP MIB, what we can do is what we find in the industry, specifically in the enterprises, is there's a lack of understanding about how to secure the management plane, how the devices are managed. They may have SNMP turned on to do network monitoring. They may have access list on Telnet, but a lot of times they will not have the anti-spoofing at layer 2 and layer 3 from the perimeter all the way into the edge network locked down. It is shown in the right-hand corner here, where we have this trusted device. And think of that trusted device as, say, your HP OpenView, your SolarWinds, whatever network, OpenNMS would be in your bottom right-hand corner there. And there's going to be a trust relationship to that router. It's in that box right above it, up here in the right-hand corner. And it may even have an access list that specifies that only that trusted device, that say OpenNMS, HP OpenView box, it's the only IP address that can go and touch that SNMP MIB on that device. But our network guy in this scenario, as he moves toward the perimeter of the network, did not implement anti-spoofing measures from the internal edge all the way out to the perimeter. And what we can do is we can use a tool like SNMP Blow, because SNMP uses UDP packets where you can fire and forget. You can spike UDP packets down the wire. We're going to use SNMP Blow here to script it up. We could easily go and roll our own tool with SCAPI or some other tool if we wanted to craft our own packets manually. But we're going to use this tool because it's nice and neat. And we're going to spoof the SNMP, the IP address. We're going to spoof the IP address of the network server, and we're going to specify in that script the IP address of the router. And because we've been doing our homework on this organization, we're going to develop a custom dictionary for that organization. And all you have to do, this custom dictionary works. You get in the head of the network guy, you go and get into the social media, you find out he's into Star Trek, he's into Star Wars, he's into Greek mythology, things of that nature, and develop a custom dictionary for the organization and feed that into the script. And it will run until it guesses the correct SNMP community string, and when it finds the correct one, it will download the router or switches configuration so that you can go and grab their username, passwords, and routing information. You get all the intel that's on that router, and then because you know you've guessed the correct SNMP community string, then you can go upload a new config, and you've taken over the network. I've used this. This works. Now, we've gotten into the enterprise router on the internal network. Now, I'm a Cisco guy. I drink Cisco Kool-Aid, that's what I know, so my examples are going to be around Cisco. You can take in these examples for how you might use them similarly for Juniper, Brocade, et cetera. I appreciate if you'd share that information with me because that's, like I said, I know the Cisco, so that's what we're going to talk about. The scenarios here, especially on the enterprise side, will be more Cisco specific. So we've broken into a layer 3 switch, a router, in the core enterprise network. Well, what can you do with that? And I work with a lot of pen test teams, and they're popping boxes, they're running Metasploit. You know, they got the techno music going, but got it blaring, they're popping shells left and right with Metasploit. Windows boxes are getting knocked down left and right. They get router configs, they find some kind of router switch configs out on a file server, get into a network guy's computer. They log into the computer, into the router, log into the switch, they get screenshots, and that's as far as it goes. Drives me nuts being the network guy. There's a whole lot we can do with those routers and switches, because what if you've got access, maybe you have only read access through some web server, you can only do directory traversal, and you can only read files, and maybe you can read a router switch config, but your Metasploit, your Core Impact, your Canvas, you don't have a day zero, none of those things are working, but you have a router config. Well, here's some things you could do. There's a capability with the Cisco routers. A lot of you guys know about doing the old cheesy Cain-enable, Ettercap, man-in-the-middle attacks. Well, we could go and use route maps and override the routing table, for example, and instead of doing just a layer 2 inside the VLAN man-in-the-middle attack, why not use route maps, basically policy routing, to override the routing table and force traffic to traverse the way we want to based on criteria that we specify using an access control list, kind of like a firewall filter if you're not familiar with that. And specify the traffic that is of interest to us, override the routing table, and then be able to do a layer 3 man-in-the-middle attack and jump VLANs so that we can influence the network. Another thing that we might do is specify the traffic that is of interest to us. Like most enterprise networks, all of the, if monitoring is in place, say they got Security Onion, or whatever your favorite vendor security solution is, a lot of it's going to be at the perimeter of the network, and we expect them to be looking, maybe they're doing egress filtering and they're monitoring egress. They got it going on, they're smart guys. Well, why not use route maps to force traffic out a backdoor connection, say out a 3G, 4G modem? And then at the same time, if you're dealing with someone that's more advanced, if you have more of an advanced adversary, it could be that they want to go and modify your perimeter router where you maybe have multiple internet connections and specify traffic that is of interest to take a path out a specific service provider where they may have more influence. That's something else that you might do. Typically in enterprise pen test, our rules of engagement, we're typically going to force traffic out a back door or maybe do the layer 3 man in the middle, because to do the scenario at the top, we would also have to have the service provider under contract and be doing a pen test against them, and that's usually not the case. It's just something I want you to think about. Another scenario, this is pretty old school, but if you haven't seen this, you need to be aware of it because a lot of the pen test teams are not aware of it, and I want you as defenders to be aware of this because the bad guys, they know about this. You can take, if you've been in the routing world very long, back when I got involved with routing, we had AppleTalk, IPX, DECnet, LAT, XNS. We had the ABCs of protocols running on our network. And if you wanted to get traffic across your wide area network and you didn't want to run every routing protocol for all the different routed protocols, you could go and run it, you could go and build an IP wide area network and tunnel it with GRE. Well, it so happens, I just told you about route maps where we can override the routing table and we can force traffic to traverse the path that we want it to. Well, we could go and build a GRE tunnel if we have access to the router and build a GRE tunnel out to a router that we own out on the internet somewhere, and then using route maps, force the traffic that is of interest to us that we define using an access list, just like a firewall filter, force that traffic using the route map over that GRE tunnel out to the internet, and then we can sniff it across the wide area network. If you're not aware of this, if you're in the enterprise and you're not aware of it, another capability that's built into Cisco and you don't have to go do a hack on the router is you could use span and force traffic out. You know, a lot of the enterprises I go into, the network guys are familiar with doing span, where they can do port mirroring on a local switch, and doing span, where they can mirror switch to switch. Well, there's a feature called span, where you can mirror out to an IP address. Now, if you have a VLAN that has got a great deal of traffic, this is probably going to, and if they're doing monitoring, you're going to get busted. But if you get into a network, you find yourself with access and it's not real busy, and you want to exfil traffic, you could use span. The switches, if they're a Cisco shop, they're going to have the feature set most likely on the switches, and you could go and set up a port mirror using span and mirror out to an IP address that you set up out on, say, maybe at Amazon, out on the web, and capture traffic. Here's something I came across many, many years ago. When I first got started in routing, I had a big customer project where we were doing DLSW. Basically, it was SNA. I had to network AS400 with the IBM controllers, the 5494 controllers, where there would be green screen terminals at remote sites that would go back, get aggregated back to an AS400 at the central hub site. And so I had to go learn this technique called DLSW, where we could take bridged protocols like NetBIOS, SNA, SDLC, which is a serial protocol that talks, the router talks to the controller that enables the green screen capability. That's the SDLC protocol. Well, I learned to tunnel that using DLSW over an IP network. And I started digging into it and discovered, because it's bridging, you see down there at the bottom, I'm turning on bridging. Well, the RFCs are specified that they intend for you to go and use NetBIOS and SNA. But with the routers, being an old crusty router guy, if you turn on bridging, the rules are, if you turn on routing for the protocol is going to be routed. Even if you turn on bridging, it's got to make a decision. So if you turn on routing for a protocol, it's going to be routed. If you turn on bridging and routing, and if the protocol is not routed, it's going to be bridged. Well, here we got bridging turned on, so the IP is going to be routed, and anything else will be bridged. And I discovered that you could get IPv6 across the network. I proved this in the lab, that I could get IPv6 across a routed network using DLSW. I thought it was pretty cool. My thing is, what I want you to understand is, I don't know if you ever watched the old David Carradine Kung Fu movies. One of the lessons, one of the lessons, Master Khan asked Grasshopper, David Carradine, there was a scenario where they got robbed, and he's like, "What did you learn?" And he's like, "I learned to expect the unexpected." I want you to learn to expect the unexpected. Nobody will, if you're a bank, I got a lot of banking customers that still have IBM networks. They have this code. Who's to say that someone would not get into their routers and do a DLSW tunnel out of their network? You got to do that egress filtering. I can guarantee you, the next network I break into, where it's inside the rules of engagement, to do this, I'm going to build a DLSW tunnel right out their firewall. If they don't do egress filtering, to show them how this could work. I think it'll be cool. It'll make great slides. So I discovered the L2TPv3 protocol because of the work we do with service providers. And what the L2TPv3 protocol does is it allows you to take a router and build what we call a pseudowire, where you can drag and drop a logical wire from one VLAN across a wide area network, whether it's your private wide area network or the global internet. And you can drag and drop a virtual Ethernet connection across the cloud, private cloud, public cloud, what have you, and connect a couple of VLANs. Now think about that. Think about if somebody gets into your enterprise router, and you probably have the feature set if you don't, and somebody has access to the router, ask yourself, would you know if they uploaded new code to enable some of the capabilities like the L2TPv3 and some others that we'll talk about? Do you have the configuration monitoring to know that the config was changed? That it was, it wasn't just an accidental reboot? That it was somebody putting some new code on the box? So we could go and enable this Pseudowire here with this L2TPv3, assuming we break into somebody's router. And think about all of the layer 2 attacks that you could do. Eric Vanek, who was here earlier in the week at the IPv6 summit, he wrote a book on LAN switch security, what hackers know about your network that you don't. Read that book. It's pure layer 2 evil. Now, he goes and shows you what the bad guys know and how to mitigate it, but all those layer 2 protocol attacks, we could possibly go do across the wide area network. And everyone is looking for those attacks. All of the stuff that you might do with a tool called Yersinia, for example, you're looking for it locally, but why can't we do it across the wide area network? We just connected the 2 VLANs. Now, Lawful Intercept, that's another feature that may or may not be in your routers. It's going to be in your routers if you're in a service provider cloud environment, public cloud, because the government is going to need to be able, when law enforcement needs to do a wiretap on someone that's under suspicion. In the U.S., law enforcement will come to the telco service provider with a warrant and say, we've got to go and get this information. And they'll provide the paperwork to show that they've been to a judge and they've been authorized to do an IP-based wiretap. If they do not have that capability in the public cloud, the WAN, the telecommunications cloud, it's like a $10,000 a day fine in the U.S. I don't know what it is in other parts of the world, but in the U.S., it's like $10,000 a day for every day that they cannot provide this capability. And in the case of the Cisco routers, your other routers, other network infrastructure, it's in the public WAN, public data center cloud, they're going to have this infrastructure in place. But this is one architecture representation of how Cisco does, and there's the references. And basically what's going to happen with Lawful Intercept is the paperwork gets served, and there's communication that is of interest to law enforcement, and say A and B are communicating, a copy of it, a copy of that traffic is going to be going to law enforcement. All of their traffic that's happening will end up getting forwarded out. That's how it's intended to work. What if someone breaks into your enterprise router, you got the memory, you got the resources, maybe you had the feature set loaded on your equipment. Why can I not turn that on and use that for my purposes as a way to sniff traffic across the wide area network and get a copy of your traffic? Yeah, I want you to, as defenders, if you're in an enterprise environment, would you detect that? Would you detect somebody modifying and configuring your router for you? Do you have configuration management in place? It's automated. Yvonne spoke yesterday, I believe it was, about automating security. Do you have network monitoring and automation to alert you when something happens to that equipment if someone was to go and enable this? Now, what if they turned it off where you didn't get notifications? At each point of the network, you want to get what visualization and instrumentation on your network so that you can see new traffic patterns that are abnormal, egressing and moving horizontal and vertically in your network in case somebody starts doing these things and they start turning off your, say, configuration management features. You've got to have visibility at layers into the network in case something like this has happened. So there's no reason that we could not go and hack the router and turn around and do that whole packet capture where we're talking to the sites that we need to be talking to across the wide area network, across the internet, and a perfect copy of it be sent to our system so that we can be making copies of it. This scenario speaks to, this is a busy chart, you can look at it offline. This one really speaks to that whole security by obscurity. How many times do you go into networks and there's major vulnerabilities that you discover, maybe doing internal testing, but you're told, well, we have mitigations. There's they call it architecture mitigations in place to circumvent it. Well, here's Here's why a lot of these problems we find are not getting fixed with architecture mitigation. You got to get out of the box with our thinking when we're testing these systems. In this scenario here, we have a cable company that over here on the right, they have a head end. Basically in the cable industry, they call their data center a head end. In the telco world, they call it a central office. But over here on the right, we have a cable company that has a head end where they have all of their computer network equipment. And they've outsourced to a cloud provider the IPTV, the cable TV streams. Now they have RF to pull the local RF channels in, but all of the digital IP, all the channels, all the sports, et cetera, they pull from the upstream provider who can do it cheaper and quicker and easier. And they stream that in over a high-speed link using multicast, and the provider sends it out not to only one customer, but numerous customers. And here at this local head end, what they've done is on the servers, because of the way multicast works, there's a capability called reverse path forwarding, where the multicast, for it to be forwarded out to the home networks here, these servers here on the right are going to pull a multicast stream from this cloud provider up in the upper left-hand corner, and for those servers to push that multicast out that head-end router out toward those homes, the traffic has got to obey the reverse path forward rule, which is part of their architecture mitigation. Because what happens here with these servers is a lot of times, I build these networks, you get something put in place, nobody touches it because they paid the vendors a great deal of money to put it in place. It doesn't get patched. Nobody touches it until somebody dies, retires, or there's a whole nother, service upgrade. But we don't touch that. You can go and upgrade the enterprise, but you don't touch that part of the network. You don't mess with people's cable TV, right? And so those are some old boxes that don't get patched. Maybe some old Solaris boxes with all the problems with that. And they're going for the reverse path forward rule. They're going to have their default route pointed back toward the cloud because that's the only way that the multicast will forward the traffic out to the homes. And so they have an architectural mitigation. If somebody tries to go and break into the network, they can't get a two-way connection. And so we test this network. We break into the router. We won't end that head in. We can't get there. What do we do? So what we discover is we can log into that router, and we start looking at the ARP table, and we see all those hosts back there in the head in over here on the right. But we can't ping them. We cannot get a two-way connection. We see all of these devices from that head-end router that we've hacked. Turns out that you can enable NAT. You can set up NAT, and even though the default route on those servers point back to the cloud, you turn on NAT, and the router will proxy the connections so you can get a two-way connection, and then you can go and break out your Metasploit or whatever tools you want to use to go and hit those systems. Again, that goes back to having configuration monitoring and locking down the management plane, because they did not lock down the management plane. In the case of this head-end router, we were able to take that router over. Pretty much anywhere where I plug in to test, where OSPF is being run, OSPF is, in any other protocol, EIGRP, in the networks I plug into, it's always EIGRP and OSPF for the internal routing. And actually, you do see some with RIP. It's very rare, but you do see some RIP out there. In the very large service providers, you'll see ISIS. But typically what you're going to see is EIGRP and OSPF in the enterprise space. And it never fails for me that I never see those protocols being secure. And all you got to do is pull up Wireshark, TCP dump, and you're seeing it being multicast out on the wire. Though there's not another router to talk to, it's being spewed out there so all the hosts can see that traffic. Now, what's going on with OSPF is how that works, in case you're not into routers, is with OSPF, we logically break up the organization. Every OSPF network is going to have an area 0. And if you have a really large enterprise network, you're going to break it up logically and segment it with sub-areas, but every area's got to touch area 0. And that helps us manage the routing and keep the routing table smaller, where we can do aggregation of IP addresses And the end goal there is to lower the CPU load in case, especially if you have links that are misbehaving, the routing tables will not be having to recalculate all the time because you've segmented the network off. So that's what's happening there. And then you got what they call an autonomous system border router, an ASBR at up there in the top left that will talk to your BGP, your other providers on the network, and then the routers that tie the different areas together. It's called your area border routers. When you go like from area 0 to area 1, that would be your area border router. But what's going to happen there, as I mentioned, you're going to pull up Wireshark and you're going to see OSPF, you're going to see EIGRP just multicasting out there in the VLAN. That is a huge opportunity. And every time I go into an enterprise network that's running routing protocols, if it's not a small medium business, they got the routing protocols going. They're flooding them out into the LAN, and they shouldn't even be there in most of the cases. And if they have authentication turned on, the authentication is clear text. Even though MD5 is an option, there's either no authentication, clear text authentication, or MD5. And the networks are always clear text or no authentication, which enables a great deal of vectors that are just low-hanging fruit for the pen test team that comes in to test the network. And so what can they do with that? Well, you could go and you could go buy your router off eBay and fire it up on their network, or go download some code and fire it up in GSN3, Dynamips. Maybe have you ever heard of the Naval Research Lab Core tool? There's a tool called Core that you can download from the Naval Research Lab. That's a network simulator that basically fires up a bunch of Quagga routers. And you could go and blow up with NRL Core. And I want you to get this. You could take that network emulator, simulation environment, fire that up in a VM that you can download off their website, blow up a really big network, a really complex network, and start feeding routes into the network and start introducing interesting IP addresses into their network. I'll let your imagination run of the IP addresses that you could go and start advertising and introducing into the network and start showing up in their logs as the source of attacks. Maybe, everybody wants to talk about nation state. Why not go and build a pseudo network in that virtual environment, join their OSPF domain, and make them think that they got a nation state introducing routes into their network and filling up their logs, and you're sitting there local on the inside. You're coming over you're coming in over wireless. You're in a local VLAN, and they think they're under nation state attack. And as a result of that, you could also, because you can interact with the OSPF protocol that is being dropped into that stub network, into that VLAN, you could also do man-in-the-middle attacks. You could go and you could introduce man-in-the-middle attacks possibly. Or you could just go and act like a router, have a higher preference, and which would be a lower cost for the routes, and maybe just drop it in the bit bucket and do a denial of service. You're limited. But up here in the upper right-hand corner, I've got a bunch of tools listed to give you some ideas of of how easy it would be to do this. BGP, has anybody not heard about all the BGP hijacking that's going on? There's a lot of accidental configs happening. I would look at the accidental configs as if the traffic that's being hijacked using BGP, if it's resulting in a denial of service where it's being dropped, it's probably accidental. If it's getting hijacked and then forwarded back out, it's probably a man-in-the-middle. It's probably an intentional attack. And here's how it would look. With BGP, you break up the network into autonomous system number. If you're in Europe, you go to RIPE. In the US, you go to ARIN. If you're in South America, South Central America, the Caribbean, you may go to LATNIC. Or in the Asia Pacific, you go to I forget that one, but you go to those organizations to hand out the IP addresses. They also hand out the BGPAS numbers that logically define an organization. Even if you're not running BGP, whoever's providing internet services for you is running BGP and advertising your network addresses that you own on your behalf out to the global internet. And if someone accidentally or has taken specific interest in you, there's an implicit trust relationship across the global internet, and somebody could start advertising your IP space as theirs. And you see over on the right, the green arrows where you have traffic that is intentionally talking to each other. Well, say up there in the upper left-hand corner, AS5 starts advertising your nets. Well, they could swing traffic over, they could influence traffic in certain parts of the world to swing over to AS5, and then they could go and set up a global man-in-the-middle attack against you. The same, and have the same results as you would if you were in the local VLAN running EtherCap, but on a global level, be accomplishing that. And I have not seen the AS number hijacking combined with IP address hijacking, but that could happen as well, where they not only hijack your IP addresses, they introduce your AS number. That's theoretically possible. And what happens is you know, the longest IP prefix is going to win when it comes to the routing. Whoever's got the most specific routes, they're going to win. Now, some of the people who are doing this, spammers, there's a lot of, there's a good paper Cisco wrote, one of the blog sites on Cisco's website, about how the spammers are doing BGP hijacking, and enterprises are coming up, their IP address space is getting blacklisted because spammers are hijacking their space to introduce email, and they haven't done nothing. Yeah. So this is something that your enterprises, if you're a large enterprise and you have a wide area network and you're going and pulling private network services from your upstream provider, you're doing like MPLS type services, whoever's doing this BGP hijacking, especially if you're an international enterprise where you have sites around the world, if the BGP is being hijacked, understand that whoever has access to the BGP routers, they have access to the MPLS routers as well. I build those networks, and we sell routers about the size of that door. I call them BFRs, big freaking routers. And what's happening in your data center where you're virtualizing your servers is happening in the cloud as well. We're virtualizing the routers where we carve up the routers virtually with the MPLS and sell that router over and over and over again. And one of the services that'll be on that single router is BGP, along with all the private MPLS circuits. And here's what I want you to understand is when the salesperson comes and talks to you, they're going to probably offer you, and you probably already bought, an MPLS VPN, virtual private network. How many people believe that VPN implies encryption? No. Our nomenclature, our words have been hijacked by the marketing people. Your VLAN is a virtual private network. If you're old enough, you've been in networking long enough, X.25 at the airlines used to use a lot. Frame relay, ATM, that is all VPNs. It's not encrypted until you go and apply encryption to it. But we all go in a lot of in the enterprises, we're sold an MPLS VPN, and we assume that it's a encrypted connection, but it's the furthest thing from the truth. And so we're fixing to go show you this in more detail. So MPLS, just to give you an overview if you are not familiar with MPLS, MPLS works at layer 2.5 of the OSI model. There's a shim that gets put between the data link layer and the network layer. And you'll have labels. Instead of, at layer 2, you're doing switching based on MAC addresses. And then at layer 3, you're forwarding based on IP addresses. Well, with MPLS, we're doing forwarding based on labels. And so you'd have a VPN label, you'd have a traffic engineering label. And what I want you to take away from this chart is someone in the cloud, in the telco cloud, starts doing this BGP hijacking and you're running MPLS services across it. I'm going to own layer 2.5 north. If it's not encrypted, the whole stack is good. Whoever's doing it's going to be able to influence and read your information. Now, from a PCAP standpoint, I'm not going to read this PCAP to you. These slides will be available. I want you to have it to reference. But what I want you to see here is between the Ethernet frame and the IP header is where the MPLS label has been injected there. That's what I got in the block there. And you can see 3 different MPLS labels. You got the label where the core infrastructure is talking, and then you got a traffic engineering label, and you also have the MPLS VPN label represented there. Now, MPLS, how does this all work? to get you educated about MPLS, which if you're an enterprise, which your service provider may have not told you. Here's how the architecture is going to work. In the core of the network, we have these BFRs, we call them P nodes, where they're just speeds and feeds, and we're forwarding traffic as fast as we can. And then at the edge, we have PE nodes, provider edge routers, and they're all just big routers, big Juniper, Brocade, Cisco, whatever your vendor Kool-Aid is. And those PE routers, the provider edge routers, they're going to have lots of interfaces. That's where they're aggregating lots and lots of customers. And at those provider edge routers, that's where your BGP is coming in. Maybe it's your local regional ISP that you're pulling services from. If you're a retail business, all of your retail offices are going, maybe that are doing MPLS, they're going to get aggregated to provider edge routers. And then out to the edge, you'd have your local VPNs. And then with that MPLS, you could have duplicate IP addresses because everybody's going to have a VPN. They're going to be segmented off and carved out, and they're going to have their own virtual routing table on that PE device. Everybody's going to be segmented off. And what I want you to get here is you're inheriting, again, going back to that talk yesterday around trust relationships, you're inheriting a trust relationship with the cloud, with the telco cloud, at that PE router. And you have to trust that guy is not going to fat finger and accidentally introduce somebody else's network into your network or your network into somebody else's bleed routes asymmetrically or symmetrically at that network. And the only way to protect yourself, there's that bottom statement there. Encryption. If you're not encrypting your own traffic and don't let the telco provide the encryption and the MPLS VPN, I mean, it's that whole trust relationship there. So here's what the router config looks like if you haven't seen it before. Just real quick, I got 2 customer VPNs defined. We're at the second line at the top. What's been declared there is a route descriptor. That's where we're using that RD there, that route description to identify the VPN with that VRF. And then those route target statements, that is the policy, and that's going to tell the router what VPNs we want to bleed in, we want to import, the routes we want to import in, and the routes we want to export out. It could be that we only want the VPNs associated with our VPN, but we could have an extranet B2B type situation where we bring in another MPLS network. Say it's a merger. Maybe there's 2 MPLS networks that VPNs have been defined, and we could use those route target import-exports to join 2 MPLS networks together that were once totally unique. All it takes for another enterprise to get their network into your network or vice versa is the network guy accidentally typing in those route target import-export statements, or they go rogue. So the only way you're going to protect yourself is encryption, because that's how fast your private MPLS network is going to be breached. Now this is what it looks like from a virtualization standpoint. If you got from an enterprise standpoint, you probably have routers in your network, and you got the global routing table in the upper left-hand corner that you're familiar with, and you do your show IP route, and you see all your routes. Well, in the upper right-hand corner is where you see you have to do a show IP route VRF and specify the VPN that you want to look at, in this case customer A, or down the bottom we have to go and do a show IP route VRF customer B, so that we can, and when we do that, we see 3 different unique routing tables. We're on one router, 3 unique routing tables here. We're like ships in the night. We're in the same water, but we don't see each other. And you have to do that import-export to be able to see each other. Now, I showed you how that WAN cloud works with those PEs tied to the P devices, back out to Ps at the edge from end to end. Well, how those labels get from the edge where your MPLS VPN is created is with BGP. And those route targets, the policy is advertised across the internal wide area network of the service provider using the extended community string in BGP. And you can look at this offline. You'll have these slides. Just want you to have that for reference, see a PCAP of it. Now, this is a monolithic architecture for a service provider. This is just a single service provider architecture we're showing here. The reason I did this, I want you to see this. This is what you got the global internet. The service providers got their own internet backbone, and then they drop down to the service provider's MPLS network, and then they have their internal customers. What can go wrong if the router guy goes rogue? What if he starts working for the bad guys and being influenced by organized crime, what have you? What can they do? What if the service provider gets hacked? The service providers get hacked. I get the phone calls. When they get hacked, trust me. I get the calls and have to go respond. They make the same mistakes that are happening in the enterprise. They just don't talk about it. So they can easily, like I showed you, go and change that VPN config, do an import-export, and introduce someone else's network. Maybe they have an organization VPN network that they want to bring into that network. I showed you that lawful intercept, that ER span of mirroring traffic out. All of those techniques that we looked at in the first part of the presentation could be done in the telco cloud with your traffic so that they can sniff traffic out. I want to call your attention that I know in the U.S., this has happened in the U.S. I talked to someone who had a private MPLS, virtual private network, VPN, that they were sold. It's private, it's VPN, right? They found that there was traffic coming from the MPLS network back out their firewall from another country. And it ain't the one you guys are thinking of. It was but there was another country coming in from their private MPLS network, and the only reason they called it is they were looking at their egress, their firewall logs, and watching the traffic traverse. They never thought, they got an MPLS private network. It's private, right? Believe me, they got encryption now. But I have to ask you this, as enterprises, if someone does that to your network, would you know it? Can you detect that egress? So, how would they take over the telco? Say if the network guy didn't go bad, how could they possibly get taken over? Well, how many of the networks, they sell you a monitored managed network service where they call it a CPE, the customer premise device, is located at the local site. Maybe it's a retail office, maybe it's banking, and they got a router spread out everywhere. Physical access rules. And if you got physical access to that customer router, if you can break into that router, if they do not have password recovery disabled, you break into that router, boot it up in the ROM-mon, and start doing password recovery, you can pull the config out, and you're going to get all the SNMP, the network management, the trust relationships of that cloud up there, that circle up there at the top, where the brains of the operation for the telco is, because they're providing you a lights-out managed service, right? Well, all the trust relationships, all the keys to the kingdom, all the good intel is in that router config out there at the hundreds of thousands of customer sites, and it's pointing back up there. And all it takes is someone to get a hold of that equipment, and they're going to know that. There's a reason I've thought about this slide. I'm thinking of a customer because I had a customer that they had one telco network with one frame relay provider. There was a totally lights out managed network. They flipped over to a second telco, and I built the second network. The first telco abandoned all the equipment in place. They just wrote it off, left it. The project manager, the Microsoft Excel PowerPoint guy, didn't take into account the exposure that he gave that telco because he left all that equipment out there in place with all the configuration information. And my customer was reusing all their equipment, so he had to do password recovery and getting all that information. So that's one vector that the bad guys could end up getting into the telco. The point being, the telcos have the same problems that the enterprise does. It's just that they don't get exposed as much as and beat on like the enterprises do, but they're making the same mistakes. And if somebody can get into that network, they could go and traverse and get themselves embedded into the optical network, the Metro Ethernet network, et cetera, internet. Once you get into that core network management operations, they have control of everything. And if whoever breaks into that network knows what they're doing, nobody will ever know it. Now, when I started working on this idea and was thinking about how BGP is being hijacked and how that could be pivoted into an MPLS attack. This is the scenario that I was originally thinking of an international enterprise where you have, say, locations in the US, Europe, Asia, South America, Asia Pacific, and you have the telecommunications person show up. You decide you need a new wide area network that, it's going to tie all your manufacturing locations around the world together. And you go talk to XYZ vendor. The sales guy's going to show up and they're going to lay out a map and tell you, yeah, we can give you circuits. We can give you an MPLS network that's global across the network. And you're going to get one phone bill, and I'm going to be your interface. I'm going to be the guy you talk to. I get the commission check. But they're not going to tell you about that trust relationship that they have, that you're inheriting with all of their different peer carriers. Just like BGP is peering to make the whole global internet work, MPLS for international MPLS VPNs is being peered. No single telco owns the local loop around the world. And to get your local loop, say from the US to Europe to Asia, Asia Pacific, South America, you're going to have to, they've got to work with lots of other telcos to build, and they're going to peer, just like they do with BGP, they're going to peer MPLS networks together. And so now, all it takes is one telco in that MPLS trust relationship to get compromised and take an interest in some traffic, and now you're compromised. And what can they do? Well, all the things that we talked about at the first part of the presentation with sniffing traffic, doing the man-in-the-middle attacks, could, use the lawful intercept to copy traffic, the ER span. All of those things are possible now anywhere in that chain. And if you're not using encryption, who knows if somebody's going to do it or not. Now, if they're sniffing, you're never going to know it. If they start messing with your traffic and redirecting and rerouting it, the only way you're going to know that they're rerouting your traffic is if you've been mapping out the time delay, looking at the TTL, because you can't break physics. There is time. But I mean, I've been in networking 20 years. I don't know many people that's monitoring the time delay of IP packets. But what you might detect if you're not using encryption is having routes injected into your private MPLS network, like that scenario I just mentioned where my contact had detected that happening to their network. And I want you to ask, this is enterprise networks, if you're buying MPLS circuits, if someone in this cloud joins your MPLS network, would you detect new routes being injected into your routing tables? Are you monitoring your routes that are being introduced into your network from your MPLS WAN? You've got to lock that trust relationship down. Put some monitoring on it. Because if you're not looking, you might as well assume that just when you go home, you might not see it. I'd probably assume they've already been there and done it. They may come back later. I'm just paranoid. I've been in this business too long. So I'm not all bad news. We can fix this. We have the technology. We just have to make a concerted effort to do it, to lock down, like was spoken of yesterday. We got to lock these trust relationships down, model our network and our assets. I recommend you start immediately monitoring your IP networks. The IP addresses that you have been allocated, your public IP space, both IP version 4 and IPv6. We're going to move to IPv6. Let's do it right. Let's do V6 right and start off monitoring our prefixes for V6. And let's go back and get our V4 addresses monitored. Excuse me. And better than that, everyone's talking about threat intel these days. It's a real hot topic. Monitor your peers. Monitor your competition's IP prefixes. Monitor your suppliers' IP prefixes. Maybe your adversary, whoever they are, whoever's interested in your network, if it's a strategic attack that you're about to become a part of, maybe they hit the supplier first or one of your peers, but you're next. Or maybe they've already hit you because you hadn't been monitoring, you didn't know it, they've already done it, and now they moved over to the other guys. If you start monitoring, BGP, you may be able to detect it. And here's a couple services you can use: BGP Mon, Dyn. They bought Renesas recently, DYN out on the internet. If you got scripting skills, you could go code your own tool. There's free route servers out on the internet called BGP Looking Glass servers, where you can log into routers and monitor and baseline performance if you have mad scripting skills. If you don't want to pay for a service and you can go. There's a site called BG Play. BG Play. You can look at like the last 7 or 10 days of routes to see what's been happening out on the internet. For the MPLS, use VPN. You've got to go and use encrypted VPN over the MPLS VPN, encrypt that traffic at the edge. If you're going to outsource, I'd get 2 providers. I'd have the telco build the MPLS network, and I'd have a second vendor, supplier, perform the VPN for me. The telco's going to want to sell you it all because that's how they get their commission, right? But you want to have somebody separate from the telco provide the VPN, the encrypted VPN service, in my personal opinion, because of that whole trust relationship. Because if that router guy goes bad or they get their network popped, so what? You got VPN. I'll use your VPN. I log into people's VPNs all the time. I log in, it's no big deal. You get the credentials, you log in over the VPN, it's just encrypted. Whitelisted traffic, and everybody's talking about application whitelisting at the host. For the network guys in the room, we need to step it up. Everybody wants to beat on the Windows guys. Network guys, we need to step it up. We've had the tools a lot longer, and our tools work, and they're not as hard to put in place and tune and tweak as the application host level. Let's do whitelisting and lock down layer 2. Let's lock down layer 3, lock down those trust relationships, lock down those routing protocols of the routes that we're having injected into our network from the MPLS carrier. And not only lock it down, but be monitoring and watching for the carrier to accidentally try to send us routes that we don't own. And then if something happens, triage it and investigate it and demand reasoning for these new routes that are not ours trying to come into our network, and monitor it and have that baseline, and use two-factor authentication everywhere. If you're not doing one-time passwords, if you're not using one-time passwords, assume your passwords are compromised. Now, I didn't come up with all this knowledge myself. I study a great deal. I suggest you can take these slides. I made them really detailed so you can go and try to save you some reading. The ERNW guys have done a great deal of research in this field. Yvonne is one of the top people in the world as well. Eric, who was here earlier in the week, I mentioned his papers. He's done a real good book on IPv6 that also covers MPLS. Look at his book. And you, of course, hope you know FX. Go and look at his stuff as well. But those are some good references for you if you need to dig deeper into this subject. And if I can do anything, I live on Twitter. Only time I'm not on Twitter is when I'm sleeping and then I'm dreaming about Twitter. So if I can do anything to help you, please reach out to me. If I don't respond, it's because I'm in the air flying somewhere, but I will get back to you as soon as I can get a good internet connection. I hope you got something out of the talk. I sincerely appreciate everyone attending my talk, and thank you again for inviting me. It's been a major career goal to come to Troopers, man. You made it happen for me. Thank you.
Very good job.
Thank you.
We might have a quick Q&A.
Okay.
Like 5 minutes.
Okay. Any questions?
Just one question. So we are all some kind of technical. So how do I tell this MPLS thing to the management? Because for us it's hard to understand, but for them they completely lost. But
yeah. Well, I would go back to that chart. I would. Most of us, especially in the enterprise space, are under compliance, and like healthcare, banking, we're under regulatory requirements to use encryption. I would take something as simple as this chart here and use the business requirement to be compliant, and lay that down and show them MPLS, no encryption. we're not compliant. Confidentiality, integrity, availability. If you're in the SCADA utility, you're worried more about availability. If you're in the healthcare banking, you're worried about confidentiality and integrity. And without utilizing IPsec with your MPLS, you do not have that confidentiality and integrity. And that's a business conversation. They understand compliance. In the US, we have HIPAA for healthcare and, you know, Graham-Leach SOX for financials. I don't know what the equivalent is in Europe, in other parts of the world, but I'm sure you have that, especially in the enterprises. And that's how I would communicate it. Just, we're non-compliant without doing this. And then if you don't want the compliance, what's the conversation is having in the US, we don't want to go and implement this, then we buy insurance to pay off everybody when they come sue us. I mean, that's what happened with Target and Home Depot, right? They just got a lot of insurance, and they cash that insurance check in, make it all go away, and stock price goes up, right?
I think maybe part of his question was the management will shoot the messenger. Why didn't you tell us before now? Why have we been doing this wrong for so long? You're fired.
Yeah, blame the vendor. I got a phrase that I came up with. I coined an acronym, the VPT. I call it the vendor persistent threat. Because it's the vendor, it's the salesperson from the telco service provider that sold this to you. Tell them it's the VPT. It's not the APT, it's the VPT, the vendor persistent threat. They sold it to you without properly educating you on what you bought. But now we don't have that excuse anymore, right? At least in this room. We understand. Any more questions? Thank you. Thank you.